Hey guys, this is the third video in my Calculus 3 series, and in this video we are going to discuss component forms of vectors. I know that in my intro to vectors video I said that the next video will feature the standard basis or standard unit vectors, but I realized that topic would make more sense if I cover a few things beforehand. I introduced the component form of vectors in my video titled A Basic Introduction to Vectors. If you haven't watched that, the link will be in the description below. I would suggest watching that video before this one. Without further ado, let's get to it. So when trying to write a vector in component form, consider this. Given the points P at the coordinate x1, y1 and Q at the point x2, y2, the vector with representation PQ is in component form x2 minus x1, y2 minus y1, and in angle brackets. And once again, the angle brackets signify that we are dealing with vectors and not coordinates. From this we can tell that point P is the initial point and point Q is the terminal point. So all we are doing here is taking the x and y coordinates of the terminal points and subtracting the x and y coordinates of the initial point. So we have x2 minus x1 and y2 minus y1. We looked at this vector in the previous video. The initial point is located at the coordinate 2, 2, and the terminal point Q is located at 6, 6. Let's stop and think what the x and y coordinates of the points really tell us. Well, the x coordinate of positive 2 over here tells us that the point P is 2 units to the right of the origin. And the y coordinate tells us that the point is 2 units above the origin. So if we move 2 units to the right and up 2 units, we have our point P. Similarly, the coordinates 6, 6 tells us that we have to move 6 units to the right and 6 units up to get to our point Q. Once you can visualize this, understanding the component form becomes much easier. Notice that when we're looking for the x component of the vector, all we are essentially doing is figuring out how much further the terminal point is from the origin than the initial point. We can look at the drawing and determine the distance between the x value of the initial point and the x value of the terminal point. So in this case, that's how we get 6 minus 2. If we were to draw it on the diagram, this 4 comes from the distance from the x value of point P and the x value of point Q. Similarly, when we're looking for the y component, we're also looking at the distance between the y coordinate of the initial point and the y coordinate of the terminal point. So if we were to draw it on the diagram, this would have a distance of 4. And considering all this, that's how we get the component form 4, 4. At this point you might be thinking that we know where this vector lies on the coordinate plane because we are given the initial and the terminal points. What if we were just given the component form angle bracket 4, 4? How would we know where and how to draw the vector? Is the component form in terms of the initial point or the terminal point? Well, if you recall from the intro to vectors video, I pointed out that although all these vectors are located in different places and have different initial and terminal points, since they all have the same magnitude, which is represented by the length of the directed line segments, and they're all pointing in the same direction, they're all the same vector. You could represent that vector by starting from the origin. So your initial point would be your origin, and drawing a line that has the same length as any of these directed line segments, and having it have it also point in the same direction, and this vector is the same as any of these directed line segments. If your origin is your initial point, so when you subtract away 0 from the terminal points, the x and y components are just the x and y coordinates of your terminal point. So given the component form 4, 4, if we started at the origin, we go 4 units to the right and 4 units up, and we get the vector representation that is equivalent to this vector representation. And once again, applying this concept and understanding to 3D vectors is quite easy. All we're doing is considering an additional z component, and thus we have the additional z component in the component form. So we have z2 minus z1, and if you're given the component form in 3D, you can also start from the origin. In that case, your component form would be in terms of your terminal point. Hopefully this video was helpful. If you have any questions, feel free to leave a comment. If you haven't already, please subscribe. You can also follow my channel on Facebook and post questions there. Check out other videos on my channel, and until next time, take care guys.